Hello everyone, this is a video lecture on how to do pH calculations, and before we get into these guided examples, I'm going to briefly go through and map out how we're going to do all the calculations. So when we're in the acid-base unit, we are commonly going to be looking for pH, because we can then use the pH scale and try to find how acidic or how basic something is. Most commonly when we're finding pH, we're going to use the hydrogen ion concentration, but today we're going to learn how to convert between several different things. So this ion is the ion donated from acids. We're also going to be able to work with the ion donated from bases, the hydroxide ion, OH-. And from this, we can solve for the POH, which is just the same thing to OH- as pH is to H+. So the way we're going to convert between pH and H+, if we want to find the pH, we're going to take the negative log of the hydrogen ion concentration. Likewise, if we want to find the POH, we're going to do the exact same thing with the hydroxide ion. So the POH is equal to the negative log of the concentration of hydroxide. If we want to go in the reverse direction and find the hydrogen ion concentration from the pH, what we need to do is so to calculate H+, we need to take 10 and raise it to the negative pH power. 10 raised to the power is the opposite function of log. So that's how we undo this process. So to find the hydrogen ion concentration, we would take 10, raise it to the negative pH power. This is not 10 minus pH, it's 10 raised to the negative pH. Likewise down here, to find the concentration of OH-, we're going to take 10 and raise it to the negative POH. There are two more calculations that we're going to be able to do, and the first one is going to be to convert between pH and POH. So if we're converting between pH and POH, what we can do is using the pH scale, which goes from 0 to 14, we see that range of 14. So pH and POH always sum to 14. So the way we're going to solve, going back and forth, if we want to find pH, we're going to take 14 minus POH. So if POH is 5, 14 minus 5 is 9. So the sum of these is 14. For solving for pH, we would do 14 minus POH. If we want to solve for POH, we're going to do 14 minus pH. All right, and the last calculation is down here, converting between the ions. Just like here, we have 10 raised to the power for the opposite function of this log. Here, the 14 is going to show up down in this calculation as 10 raised to the negative 14th. So, if we're going to calculate for the H+ ion concentration, we're going to take 10 to the negative 14th power and divide it by the concentration of OH-. Again, same calculation. If we're going to calculate for the hydroxide ion concentration, we are going to take 10 to the negative 14th and divide it by the hydrogen ion concentration. So using this map, let's do some guided examples. Let's go through and practice. So the first question says, what is the pH of a solution that has a hydrogen ion concentration of 2.5 times 10 to the negative 5th? So we're converting right here between pH and H+ ion. So we want to find the pH, so we're going to use this. We're going to use pH equals the negative log of H+. So the pH is going to equal the negative log of the concentration of H+, which is 2.5, times 10 to the negative 5th. our calculators, the way we're going to plug this in is we are going to plug in negative, not minus, negative log of 2.5 times 10, remember use the E button, times 10 to the negative fifth. Okay, so our pH is 4.60. All right, let's try another one. So number 2 says, what is the pH of a solution that has a pOH of 11.3? Go back up to the top, we're converting between pH, pOH, so we know that they are going to sum to 14. So if we're trying to find one, we're going to take 14 minus the other when converting between pH and pOH. So here, what is the pH? So the pH is equal to 14 minus the pOH, which is 11.3. So the pH here is 2.7. All right, the next one. What is the H plus ion concentration of a solution with OH minus ion equaling 4.8 times 10 to the negative fifth? Here we're converting between hydrogen and hydroxide ion. So that's this step right here at the bottom of our little guided map here. So we want to find the concentration of H plus. So that's going to be this one. So H plus is equal to 10 to the negative 14th divided by OH minus. So 10 to the negative 14th over concentration of OH minus. 4.8 times 10 to the negative fifth. So if we use our calculators, we see, let's see, 10 to the negative 14th divided by 4.8 times 10 to the negative fifth. So we get 2.08 times 10 to the negative 10th. And this is our concentration of H plus. All right, just two more. The second to last one. What is the concentration of OH minus of a solution that has a pOH of 1.7? So if we go back up, we're converting between OH minus, pOH, and we know pOH. So here, we know pOH, we're trying to find OH minus. So OH minus is equal to 10 to the negative pOH. So concentration of OH minus is equal to 10 to the negative pOH, 1.7. So again, we plug this in our calculators, and it actually comes out pretty nasty. We don't want to keep the answer like this. So we go ahead and we put in 10 raised to the negative 1.7. Okay, and we get 0.0200, because the 5 rounds up to 9, which rounds up to 9 and then the 1. So the concentration of OH minus is equal to 0.0200 molarity. We should put molarity on our concentrations. Okay, our last calculation. What is the pOH of a solution with a hydrogen ion concentration equal to 0.0096? So we're going from H plus to pOH. So if we go up here, going to H plus from pOH, we're not going to be able to get there in just one step like we have been. We need to take two steps. We can either go from the pOH to the pH and then down to H plus, or we can go from the pOH to the OH minus over to the H plus. Either way works. I'm actually going to do both just to show you that they're the same. So first I'm going to go pOH to pH and then down. So I'm going to take 14 minus my pOH. Then I'm going to do 10 to the negative pH. So we know, we want to find pOH. So we're going to go in the opposite direction. So H plus, we know. So we want to go H plus up to pH over to pOH, or H plus over to OH minus up to pOH. So we know the H plus. What we'll do is negative log, then 14 minus. So to find the pH, we can take the negative log of the H plus ion concentration, or the negative log of 0.0096. Negative log 0.0096. So 2.02. So the pH is equal to 2.02. Then if we want to find the pOH, we just do 14 minus that answer. 14 minus 2.02. So our pOH would equal 11.98. Now, if we want to try to go the other way around this guy, or around this map, so before we went from H plus to pH to pOH, so we went H plus to pH to pOH, we could also go H plus OH minus to pH. So if we went this way, or on the bottom and then the right side, we would do 10 to the negative 14th divided by the concentration, and then negative log of that concentration. So we could say that OH minus is equal to 10 to the negative 14th sorry, 10 to the negative 14th over 0.0096. So the concentration of OH minus will be equal to 10 to the negative 14th divided by 0.0096. So this is 1.04 times 10 to the negative 12. 1.04 times 10 to the negative 12. Okay, now to go from OH minus to pOH, we would do the pOH is equal to the negative log of that answer. Negative log of 1.04 times 10 to the negative 12. So the negative log of that answer is again 11.98. It doesn't matter which way you go around. Both ways you're going to get the same answer. It doesn't matter to me. You only have to go one way. But what I would like you to do is continue onto the back of this worksheet and turn it in before the end of the period. All right, have one.